Welcome to episode 5 in the Creating a Shadow Switcher series. The game's creator has granted me permission to post this content. In the video, we will expand upon the previous video by adding in the enemy class and by animating some of the background tiles. Alright, where we left off in the series, we had a little bit of player movement. We created a player object and we're able to move them around and do a few things. I kind of debated how to go about this next episode. I was kind of wondering, should I just skip ahead a little bit? But I think that leaves out some detail, especially for the beginner. My next thing that I want to implement here is the enemies, bring them into play. But before I do that, I want to make some changes to the collision a little bit, the collision logic, and we'll do that first. So right now, what we're doing, we have this a little collision detection, but what I want to do is put this in a sub. I want to call it collision detection, or check for collision, or you know, something like that. And we're going to kind of pull all this code and put it in that sub there. And let's see, let's put in here, we'll call it self.checkCollision. Just for now, let's see if that still runs, or did we break it? Yeah, so it's basically the same. We didn't make any changes. I don't want to use group collide. I know I talked about that in the previous. I want to use sprite collide. So I want to use that. And it's very similar. So instead of pygame.sprite.group collide, we're going to do sprite collide. We're just going to say self is what's being passed down. And we're going to say comma the self.gameMap. This fourth parameter, I think we need to make that a mask. Hold on. I don't. Let's see if that works. So we're okay. There we go. So I was trapped in there. Okay, right now it's trapping it in there. So it's kind of working. It's detecting, you can tell, it's detecting collision. And then the other thing I want to do is have the objects, the block characters, I want them to kind of do something when there's a collision instead of the player handling that. And I know that can be kind of a confusing. So instead of me checking it here, like this, I'm still going to loop through, but we're just going to comment out, and we'll do block.manage player collision. So we'll have to create routine in the block class. So we'll come over here to block, and we'll create a new function, manage player collision. Have an S on that? No, okay. Self, comma, player. The player, yeah, so the player object is being passed down here. Self is the block, refers to the block itself, and then the player would be the other class object being passed down. If there's a collision with an object, we're going to turn off falling. So we're going to say player.falling is false. And here we can do some collision checks. So if the player rectangle at the bottom minus self, which is the block, rectangle, the top of the block, if you subtract those two and it's greater than or equal to 4, there's going to be another if statement here. But what we wanted to do is we want to say player.rectangle.left is equal to self.rectangle.right. I know that's confusing, making it so you can't go past, or you can't go into the block, if you will. But there's a little bit of leeway on it. So I kind of worked out, if you do the absolute value of the player.rect.left minus the self, which is the block.rect.right, and if that's less than or equal to 4, and that's just a tolerance of pixels, then do this. And then we'll return. Oops, I got to do my parent. Yeah, we're good there. Oh, and I got my colon here. And then we're kind of want to do that. So that kind of handles the left side, but we want to do that again with the right side. So we're going to say elif the absolute value. Actually, yeah, we'll do it that way. Absolute value. The self.rect, which is the block, dot left minus the player.rect dot right is less than or equal to 4. Then we're going to do the same thing here, kind of. Oops. Except we're going to do right and left. And that'll handle left-right collision with the, it'll kind of move the player around when it hits the block. That way the player doesn't have to do that inside the player routine. And then if I kind of copy this, I don't know if I need to copy that. I want to kind of do the same thing for top and bottom. So if the self.rect.bottom minus the player.rect.top is greater than or equal to 4, then we're going to do player.rect.top is equal to self.rect.bottom. And then I was adding 1 to put it 1 pixel above, and then else, elif, and I was kind of copying that. Yeah, so we're going to do that. We're going to do this. If it's not that, then we do this. And then if it is that, then we're going to set it for the top. Bottom. I'm going to save that. So what this is trying to do is move the player either to the left of the block or to the right of the block, or put the player on top of the block or on the bottom of the block based on a threshold of some kind. And I was kind of working out the math. This isn't the cleanest way of doing this. I'm not even sure if this will run. So let's try it. So let's see. So see how it pushes it up there? That's kind of not quite what we want. It stops still. Now, we have the block object right here, but we want to do a similar class, but have it for, we'll just copy it and create a ladder class out of it. We'll do a new file, ladder.py. And we'll paste that in, and it's pretty much the same. We're going to change the title up here to block ladder. We'll do, yeah. I don't think we're going to need this, at least not verbatim. We'll make the ladders green, the ladder block. We don't really need this if it's just doing a pass, but it's there. And then for the collision, because this is the way the block was doing the collision, we're going to take that out, and we'll just leave in the player falling is false. And let's save that. In order to make this work, we need to call this somewhere. We need to instantiate it, and that's done in the game object, or source, if you will. So right now we're kind of, for every object that we read in, we're making it a block character. But now we got to treat it a little differently. And so for each value here, what I think we want to do, yeah, we're going to have to make this a little more. So we want to somehow, I think we want to make it like a select case. We're going to say match value case. And we'll do case, and then the value for a ladder I think is 5 because it's showing it right there. So I think we'll say case 5, and we'll take this if statement out. We'll have to deal with that in a minute. And we're going to bring this up. tab it over, and we'll kind of copy this one, paste it in, tab it over, except now we're going to do block ladder here. Oh, it doesn't see ladder here, so we have to import it at the top. So that'll import that class. Go back down to the bottom. Case underscore. So basically like a case else. And I think that'll make it run. We still have this underline right here. All right, I think I see, kind of like I have down here, block.block. I got to do block ladder dot block ladder. So the first one is lowercase right here, block ladder. And then the second one is capital L, capital B, and it should be capital L. And we'll run that. Still doesn't like it. Hold on, what am I doing wrong? All right, I see what it's complaining about. Because I want it to be a block ladder, I'm just gonna call it that. There, now it's green. Okay. Let's try running it once more. Aha. So now I can go up the ladder. Now I can go down the ladder. And I can't go through the walls. So the collision is kind of working. There's some work that needs to be done. Like when I'm on the ladder, go left and right, I can't go into the wall. That's because the block code is preventing that from happening. But now I think I have enough done to where I think I could add in the enemies. We got one dude moving around that's just a rectangle, and eventually I'll change that to an image. But now we can do the implementation of the enemies with the enemy class. All right, in this segment, we're going to go ahead and add the enemies into the game. And I'm going to try to speed it along because I didn't like the previous segment, how long it took for us to get from the start to finish. So I'm going to paste in some code. Now, what I did originally was I took the player class, copied and pasted it, and then I started making tweaks. Well, we're going to go ahead and create a new file for enemy, enemies.py. If you look at the player coding here, it's basically the same, but I'm going to paste in some code for the enemy. Now, one of the differences you'll notice in here is the direction, the initial direction, I'm setting it to a random between 0 and 1, which means left or right. The enemy could start moving left or right. And then under in the collision section, instead of saying manage player collision, it's now saying manage enemy collision. And then if it returns back that there was no collisions, what it can do in this case, if that happens, that means it's on the edge. Like it's going off the edge of a block. Let's say it's moving left, and it's about to fall off. Well, what you want it to do is bounce back the other direction. And that's what this does. This is saying change the direction to the opposite. If it's a 0, make it a 1. If it's a 1, make it a 0. And it's doing that through the use of an exclusive OR. The exclusive OR operation in Python is this up caret. This is a nice page. This W3 Schools has all these Python operators. One of them, of course, is the exclusive OR. And so it's going a little bit off topic here, but I just wanted to explain that and show you can learn more about that. It's kind of a bitwise operator. And then what we have to do in addition to this is we have to go over to, so I'm going to save that. In the game, before I make any changes anywhere else, we have to instantiate somewhere the enemy has to be brought in. And you do that, I was thinking, right about the same time you bring in the player, we can bring in the enemy. So we're going to create a variable self.enemy1. That's the beautiful thing about using a class. Once we have the enemy behaviors working properly, you could spawn as many enemies as you want. You could have 1 enemy, 0 enemies, you could have 100 enemies, and they would all behave the way you coded them in that class. So we're gonna say is equal to, we're gonna have to load it up here in the import enemies. And we're gonna say enemies.enemy And then we're gonna pass down the parameter self. For this first position, it's 870, 400. We're just gonna hard code it initially, and then we'll get to how we position the enemies later on in a future episode. We're gonna make them white, and in my settings file I have some colors and some definitions. I'll take a look at it real quick. So these are the basic colors we have: black, white, red, yellow, and green. We have some definitions for the widths and heights and just some basic stuff. And then I put also up, down, left, and right. So 0 and 1 is left and right, and then up and down is 2 and 3. So let's go back to the game object. That will instantiate it, but we also want to save it off. We're going to have to create a enemy sprite group. I don't know if you have to, but that's the way I did it. We have a player sprite group, and then we're going to have an enemy sprite group. We'll go enemy. Down here, we'll add them in self.enemy_sprites.add. So we're going to add in this enemy, self.enemy1. That should be enough just to get the enemy on the screen. He might not behave the way I want it to yet because there's some collisions detections that needs to be implemented. Let's just see if it does at least do that much. Oops, I got a typo on line 49. Okay. Oops, I didn't see that. Oh, I spelled something wrong. E-N-E-M-Y. That's easy to do. I should have noticed that. Save. Okay, so he's not showing up. Let's run that again. Did it show up and disappear? No, he is not showing up yet. Okay, we gotta deal with that. All right, I just forgot to put it in the draw routine and the update routine. So we're doing the player sprites update here. We need to do the enemy sprites update now. And then on the draw routine, the same thing. I'll just copy that. Now maybe we'll see something. I was afraid that was going to happen. Let's go to the block. Block and ladder needs this attribute, the enemy manage enemy collision. So let's bring that in, but blank. Just to see if we see something. We'll do a pass. In other words, have it in there, but don't do anything. And we'll do it also on ladder. It's still going to have some problems, even if it does run. Which it's not. I'm not seeing anything yet. I think I see my mistake here. This is supposed to say I did copy paste. It should say draw. Duh. There. That is a huge mistake. Then we got to draw self.screen. It's easy to make mistakes when you're copying and pasting things. There we go. See, he has no collision and he's moving. Okay, that's something, right? Let's watch that again. Now let's add the block collision. And it's easy for me to say, so we're going to go in here, block. We got the player collision. You can say, oh, just copy and paste player. And that's where I started. But I'm a little further along, and in the interest of time, I'm going to paste in my enemy collision that I've developed at that time. Oops, I got two of these. And it's very similar to the player ones. The player one does it like this, but in this one, we're doing something to kind of account for the ladder. If they're going up the ladder or down the ladder, once they get to the top or bottom, it needs to move a random direction, either left or right. And then basically the standard collision there. And then there's also some collision code that needs to go in the ladder routine as well. So on the ladder, we're not really doing anything here, but I'm going to paste in some code just like I did on the other one. And it's also going to handle the movement when it pertains to the ladders and how it should position the enemy. So let's just see if that will run verbatim as pasted in, and then that will get us all caught up. Okay, so now right now he's too low, so let's adjust him in the game object where we instantiate him. Let's go 380 or something. There he is. He's kind of one character too low. I don't have collision with enemy yet, but as you can see, that's kind of working. It's moving the enemy around. He moves left and right randomly. There are some problems in terms of randomness right here. Like, he doesn't want to go back down that ladder. But that's some kind of those buggy stuff that I deal with later on in this project. Now that we got one, let's go ahead and instantiate another. Let's just copy paste it, and we'll have two enemies running around. We'll do enemy 2 and enemy 2, and we'll move them a little bit. We'll go offset them a little bit on the horizontal. Boom. Yeah, now there's two enemies, and I have player, so I can move my player around. I have a little bit of collision. And it's not perfect, but hey, that, you know, it's a good start to the project. Oh, look, they're basically on top of each other right there. Oh, and look, I can't move through the background up there either. But yeah, anyway, I think that's a good start. We got the enemies in. And what I want to do now, I'm going to kind of fast forward a little bit. We need to get the animations going. So let's head on to the next segment. Okay, let's see where we left off in the previous segment. What I wanted to do was start creating some animations, and right now there's not anything really on the screen that we can animate. So let's do that. I want to bring coins to get them displayed, and the lightning. This is a rough representation of level 1. So let's do that. So what I thought I would do is copy block ladder, Control C, Control V, F2, and call it block coin, and then rename this to block coin. And we'll get rid of, well, we have to change some of this stuff here. The enemy collision, we'll just kind of comment that out and do a pass. And we'll leave player collision the way it is, and then we'll have to create an update one, but let's just get it displaying first. So we'll go over to the game, and we just got to expand this. We'll sort of take maybe copy 5 here, and in this case, from experience, I know it's a 7 for the coin. The asset, if I have it in, I don't have it in there, I'll need to copy in the coin. At this point, it's not going to be animated. I just want a still image of the coin. So we'll say block, and we'll have to import it. And you see, as we add more and more of these classes, how it starts to get messy, if you will. There's a better way of doing the import. To me, it's cleaner. You say import, you go from classes. So we'll create a folder called classes and put all of our classes in that folder. So we'll say new folder. And then if we copy in, like, I don't want to put game in, but let's do all the block ones. Block. Let's see, block. Move that one in there. So we'll just put those 3 in there for now. So we'll say from classes, import, block, ladder, block, coin. And then we'll put that at the bottom. Since player and enemies and game are, I do need import game here. Wait, no, I'm in that. Since those are the main ones, I'm not going to throw them in that folder. And I'll hit save. Now we still need that coin asset. Let me drop that in. Okay, so it's coin.png. So let's make sure that our game here has the right path. Coin.png. Save that, and ultimately have to try to run this and watch it crash. Let's see if it works. Don't be negative. Okay, it didn't crash, but it didn't display the coin either. Okay, let's try to figure that out real quick. So to figure that out, I was looking at Charpad and opening it up, And you'd basically count. These are my characters, and you go 0, 1, 2, 3, 4, 5, 6, 7. So it is 7. I just resaved this map out, saved it out over, because I think it was the older version. With that, now we have the coin on here. It's not animated yet. We'll get there. But while we're at it and we're on this roll, I thought we would go ahead and put the lightning on there. What we will do is we'll copy the coin class, F2, and rename it to block lightning. And then we'll go and change the class name. For now, I guess that's close enough. We'll go to main or game. Make sure it's imported. And then at the bottom, in this case, my research tells me it's 16. And we need to bring in the lightning, or bolt, as I was calling it. And I'll drop that in right here. Is that? No, that's the piscal. Yeah, so that's not in there. And voila, there it is. It's just going to be a still image. In fact, that should be enough to get that bolt to display. And of course, that didn't work. So I need to try to figure out why that didn't show up. And then it occurs to me, yeah, you didn't change the class down here, so that's why. That's at least part of it. Gotta be careful copying and pasting stuff. Then as I investigate, I realized the bolt wasn't even in there. So I was running an old copy of the map. So now we have all these items in here, including the one little bolt. And so it should draw a little, that kind of line going there and there. I just need to export this map out. Oh, block lightning. Oh no, I didn't see that. Just little things like that can throw you off, and sometimes can cost you hours. And the lightning's still not there. Oh look, he climbed up there, that's a bug. And then I discovered the reason why it's not displaying is because it's displaying it in green, and the background right now is green. So we're gonna go yellow. And there it is. And there's no collision with it, I don't think. Yeah, so you go right through it. Also, we want it to flash either on and off, and then we want the coin to be animated. And I mean, we could do this brick while we're at it, but we'll get to that one later. Before we get to the animation, let's look at the lightning just to show the collision. Notice I have some print statements in here from debugging. If I go in here and I say for lightning here, if I said, if we check the color, if there's a collision and the color is off, or it is actually activated, so if, and that is defined by this self dot, we're going to create a variable here, self.alpha. We're going to set it to 255. Let's see, we're going to do some color stuff. Here we're setting it to yellow. But I gotta play with the alpha values, which is basically the brightness, I think. So we're gonna do, instead of the image fill, let me highlight that. What we'll do, self.image.set alpha 255, and we'll set a variable called alpha. And then down here, if self.alpha is 255, then print dead. Alive, but that's going to print all the time. Take the pass out, you don't need that anymore. And oh, actually this would be in the, we'll want to do this in the player collision, not in the enemy, duh, right? I was doing that in the wrong spot. Okay, man, if I get that right, that should at least, when I highlight over it, it should say you're dead. First, let's see if it displays the bolt anymore. It does, but now it's black, okay. And oh, it's not saying alive. Okay, but if I highlight dead, like dead, I don't know if you see at the bottom, dead. So that's a detection right there. That's how you know if you touch that lightning bolt when it's active. That's how we know that we're in this dead state. Now, okay, so that's a little bit jumping ahead, but that's the animation. That's a bug I have right here. I'm not worried about that just yet. In this segment, I'm going to cover switching the graphics modes. So we're loading all of these images in separately. I don't even have them all listed here yet, but what I want to do is use a sprite sheet. But in order to do that, we have to look at a few things. We have to export our graphics as JPEGs or PNGs, and then import them into one sheet using a software package like Photoshop. But in my case, we're going to use the free version of Photoshop, GIMP. But before we get to that, I wanted to bring in the lightning and Piskel and just show we have these frames here. We don't have to use all these frames. Ultimately, I think I'm only going to go with 3 out of the 4 frames. But I just wanted to show that when you're in this Piskel website, which is a really neat website for doing these easy, quick animations, you have these options down here to export. So on the PNG option here, you can say I want 1 row. So we can go, I don't want to do 4 rows, but if we did 4 columns and 1 row, and then when you open it up, well, that doesn't look good. Hold on. It's hard to see that. But they're all the frames are here. 1, 2, 3, 4. And these are 32 by 32. And we just got to make space for them. Let's do the next one, the coins. So I have the coin here. Here it is animated. You can change the frames per second right here. May or may not be the final one. Probably, I don't like messing with the graphics too much, so it could end up being the final. But if we hit export and we go 3 frames, 1 row, download, and then we open this up so we can see them there. So there's your 3 frames. And then you can take these individual sheets here and we can kind of combine them in GIMP. And I mentioned that I think in the first video that I was using GIMP. So let's go into GIMP and maximize it and do file open. Shadowswitcher.xcf is the extension, XCF. And you can see this is one of the earliest sprite sheets that I was working on. I had to make it three down, or is it 2 down? No, it's 3 down because the doors were a little taller, this exit door. I put in the characters yet. I don't have them yet in this video animated, but I wanted to focus on the lightning bolts and the coins. So we got them in here. These are all 32 by 32 grids here. I think you could even, in GIMP, you could turn on or off the grid. You can select configure grid, and we want to do 32 by 32. And then that will show the pieces. So like this would be the top piece, the bottom piece. And with holding the control key, you can zoom in and out. Control and your mouse wheel, you kind of zoom in. And then when you're happy with your sprite sheet here, when you get all your sprites in there, what you want to do is you go File, and then you're going to save as or export as. And right here, when you're about to hit save, this is important. We want this compression level to be 0. I know that's important because we don't want it compressing this at all. And then just hit export. And then there it is. Now we got to code it in Python to chop these dudes into little chunks in memory so that we can index them with a variable via an index. So like sprite sub 0 would be this first one, sprite sub 2 would be, or 1 would be this one, etc. First off, I want to give credit to Coding with Russ for giving me the idea and some of the know-how, actually all of the know-how to learning how to create a sprite sheet. On his tutorial, he does a sprite sheet that's 32 by 32 with horizontally strewn across. And so I used his concept and idea, and then I modified it a little to what I needed, because I needed the cases to be 64 instead of 32 and so on. So anyways, I wanted to give him credit for that, and it was an excellent, really good video. The first thing that I wanted to do is go back into the game, and under new, somewhere in here, we're going to create these sprite sheets, and I need an array. And I'm going to paste in my variables here. What I wanted to kind of demonstrate with this, All right, so we have this animation list. That would be the main variable that I'm going to set up. That open and close bracket, I think, just means there's nothing in it. It's an empty set. Then on the steps, this would be the number of animations. So like each sprite in here, we're calling it a sprite, but it's an image, a graphical image. If you look at it from going down, it has 3 frames. It's 32 by 64, the first one. The next one is 2 frames, and it's 32 by 64. And what it's referencing is this. These first 3 are climbers. That makes up the first index, 0. Then these 2 is 1. Then these 2 is 2. These 2 here are 3. These 2 make up 4. These 2 is 5. That makes the bolt 6. And then that second parameter is 0, 1, and 2. And so on. Then I go all the way down. So the idea is, as you read it in, there is a program that you need to write to chunk that up into its constituent parts. I don't purport this part to be easy, or definitely not easy to explain. So what I'm going to do right before we do the read next level, I'm going to add in a quick routine. We're going to have to create a new class. All right, so we'll do the class first. What we'll want to do, we'll create a new one here. We'll call it spritesheet.py. We'll import Pygame. We'll create a quick class called spritesheet. And we'll help with the initiator. And we're going to pass down an image portion to it. Self.sheet is equal to image, so we're going to create a local variable called sheet, and then another function to get the image. And on this one, we're going to pass down the frame, the offset, the width, and the height. This is how we'll grab that particular image. And the image is going to equal, and this is where it gets it's a little confusing. So we're going to Pygame.surface width, comma height, so it's doing a rectangle, comma Pygame dot SCR alpha, so it's kind of the color portion of it. And then we're going to image.blid it into self.sheet at 0, 0, comma the offset 0, the width, the height. So essentially what that's doing is it's going to copy it into that variable, and then we're going to return back the image. And so now when we go back over to game, we're going to make sure we import it in. And then we're going to add in that new function here to read it in. So we're going to call it read spritesheet. And this part, okay, so we got to read in the sprite sheet itself. So we're going to say this, we're going to create a variable sprite sheet image is equal to pygame.image.load. So we're going to load in from the assets folder this thing right here. So might as well copy the path. So we're going to say assets / and then the path. And then we're going to say sprite underscore sheet is equal to, now here we're going to instantiate the class we just created. And I think I called it sprite sheet. Hold on. Spritesheet.spritesheet. And then we're going to pass down the image that we just read in, which essentially is this. So now we have the entire sprite sheet in memory. We have to loop through it and set up our variables. In order to save time, I'm just going to paste in this, because I've already worked this out and kind of watched Coding with Russ's video, but I had to modify a little bit of it. And so we're going to loop through based on however the animation steps, all of the animation steps, and we're going to read them in, and we're going to increase our offset with each one, and we're going to increase our step counter with each one. And we're going to build this animation or our sprite list so that we can index it. So sprite 0 will be at index sub 0, sprite 1 will be index sub 1, and so on, so that we can set that up. But then in order to, I'm going to save that, in order to start using that, instead of on the block classes and everything how we're doing, we're passing in the character and then we're actually loading in the path from the image, we can't do it that way anymore. So we have to change all of these, and luckily it's only 4 of them. So for example, on this one, I'm just going to comment it out, and instead we're going to say self.image is equal to, we're gonna have to pass down an index up here instead of the character, but I'll get to that. Self.game.animation list, that's the list, the variable that we just created. Self.sprite index, that's gonna get passed down. If it's, for example, if it's this, the lightning bolt, we're gonna say sub 0, so sub 0 would be this first one, sub 1 would be this one, and sub 2 would be that one, etc. If that kind of makes sense. That's how I was kind of working it out. So we're going to say sub-0 here. Not sure if you need that sub-0. That's how I was working it out. And then up at the top, instead of the tile path, we're going to, I don't think we need the char either anymore. So we're just going to pass down sprite index. The sprite index. Put the X and Y at the end. And then we'll do this down here where we read it in. So for a normal block, we're not going to pass it down the title anymore, or the tile, I mean. I'm going to comment that out, and we need an index here like 0. Do I even have, hold on, and we don't need value at all, but we need the X and Y. So, wall X, wall Y. Let's look at our GIMP. So the brick is way down over here. So what I've done is in the settings file, we need to bring in our indexes, and I'm going to paste those in. So we have our bolt at 6. Now that we have that, let's do the coin. Let's save that settings. And it's the same thing with the coin. We're going to comment out this guy. In fact, we can comment out this one and copy over the other one. So we'll do block and lightning now. So in this one, we're basically the same here. And then up here, we're going to do sprite index. And then on lightning, sprite index, doing the same thing. And then comment that one out and paste in that. Save each of these. I don't trust the save all function. And then go into game. I don't think I finished my index right here. So on the index, looking at the settings here, where is it? I have anim_block. That's what I want to use. We're going to say settings dot. Oh, okay, they show up here. Anim block. Same thing for here. Oh, this is wrong. Hold on. I don't need wall X and Y. They already got. I want those at the end. So we're just passing down. We're going to pass down the self, the settings of the animation, because we need to pass game down, and then we need the block and the width and height. We might be able to get away without the width and height, but for now, that's what we're going to do. We're going to comment out these, this. We'll leave ladder alone. And we'll see what problems we have here. I'm sure it's going to be a whole bunch. Okay, so now we're talking in block.py. We didn't comment out something out. These guys. Don't need them anymore. Block object has no attribute game. Give me a second. I got to fix that. We have game, so let's do self.game equal game. We do need to put that in. A little oversights like that. Oh, I got to pass game in. I didn't do that. So, all right, self game. Yeah. And on the coin one, the same thing. No object attribute animation list. Okay, give me a second on that. I think what I forgot to do on this is in the game, forgot to call that function down at the bottom to read in the sprite sheet. Right here. I hope that's all it's complaining about. No, there's something else. I think what's happening is reading the level in, so it's trying to, this needs to happen ahead of that. Let's put it up here at the top. Because later on I reorganize this. Just trying to adapt it for an earlier version. Okay, so now we have a different error. Step counter. That's just an oversight. I didn't initialize. That program uses a variable, so called step counter. Spelled that wrong, so on the sprite sheet, I should have noticed that. It's SRC, I think. Okay, so I have something weird there. Yeah, I have some parentheses. Offset, comma 0, comma width, comma height. Yeah, okay. Gotta be careful. Oh, okay. So we need to come in here, just like self.game, we need a sprite.index. I guess I could have referenced it directly. Need that on all three classes. One of these times we'll get it to run. Okay, when these got it running, it read in the sprite sheets. There, you could see there's some issues, and before we can address animation at all, we'll have to fix the color issues, which is a whole nother problem. Okay, my first stab at the color, I'm going to clean this up a little, get rid of some of the comments. Definitely don't think we need this anymore. We got the self image, mask. Maybe that alone. We got the color image. We don't use that. Ah, okay. That definitely is better. And then let's get the same changes. I'll fast forward these changes, but we don't need these changes. Okay. Now the color's fixed. I can work on the animation. The first animation is really fairly easy to do, is for the bolt, for the lightning bolt. Let's do that one first. So on the, to do this changes, we're going to need to create an update routine. So we're going to say update self, and then we want to have some kind of a counter. So we're going to call it a color value counter. And we're going to increment it by 1, and then we're going to say if the color value is greater than 60, then set the color value back to 0. So that's the first thing we'll do. And then we just kind of check on it, like every so often. If the color value is greater than 20, I'm trying to do it in thirds because there's 3 animation frames. Self.alpha is equal to 255, which means we can see it. If the self dot color value, and we're gonna say mod 5, just for example. Then we're gonna increase the frame. So frame, we'll have a little frame counter, we'll create it. Frame plus equals 1. Increment the frame. If the frame, this isn't the best way to do this, by the way. This is kind of my first cut at it. If the frame is equal to 2, then we'll set the frame equal to 0. And then we'll just check here. We'll set the image. Self.image is equal to self.game. Except we're going to say dot frame. Oops, I spelled it wrong right here. And then we're going to do an else. Self.alpha is and self.image set underscore alpha self.alpha. So up here we set it to 255, and then down here we set it to 0. That's convoluted, I get it. It could be better. And it's not working. Okay, let's make sure we're updating the lightning. Self.update or self.game map. So we have to update the game map. We're updating the enemy and player sprites, but we weren't updating the game map. I'm hoping that that's it. Now we have an error. Okay, at least it's calling it. Okay, we don't have a value for color value, so let's initialize it up here. Same thing. So we create some of those variables on the fly. Sometimes it lets you get away with it, sometimes it doesn't. Okay, so there you go. Now we have lightning bolts that are flashing or not flashing. And then if we hover over it, alive, dead. It's printing at the bottom from that print statement I put in the earlier segment. And then now I think we're going to do something similar but different for the coin. We'll get those animated. So let's go over to the coin. Let's take out some of these comments. And down here, create a update function. So every time the game updates or the map updates, this function gets called. Oh, and we're going to do a frame up here. So we'll set a self.frame is 0. So we'll initialize the frame to be 0. Now in this one, what I ultimately ended up doing, I went into settings, and just for the coin, I set up some coin animation frames. So you got frame 1 is every 10, and then I multiply it by 2 for 20 and 30, just for like how long you want to leave that frame running. And I put that in the settings file. All right, so we're going to say self.frame plus equals 1. Now, if the self.frame is greater than the settings dot anim underscore coin underscore frame underscore 1 colon, then we're going to set the self image, basically this line here. Yeah, sprite index 0 for the first one, and then we're going to copy it and paste it, and we'll change this to a 2, and then this to a 3, and then we'll make this a 1, and this a 2. Oh, and then the last one, of course, we got to set the frame is to 0. So it goes 0, 1, 2, boom, 0, 1, 2, okay. Or 1, 2, 3, 1, 2, 3. And now we have the animation. I know it's hideously ugly with that green background, but now the characters are animating on the lightning bolt and on the coin. Okay, see how I'm going through the coin? There's a real easy collision for that, because the coin is something you want to disappear when you hit it. In the coin player collision, if we just say self.kill, That means kill the item that you touched, that the player touched. So I'll demonstrate that real quick. So go down to this coin, and as soon as we touch it, boom, it's gone. So it's just like you collected the coin. All we have to do is add some sort of a scoring system. So that's how easy that is in Pygame after several hours, right? Anyhow, I hope you enjoyed this video. That's all I got for you on this one. I'll try to come up with something good for the next video. And until then, thanks for watching.